Today we continue on 2D milling. I will focus on we already established on the first operation, the stop operation. As we can see from the simulation, we perform the facing operation, roughing operation to clear the material, and then we do contouring, and then we do 2D pocketing, and then drilling, and then we do a chamfering, threads, and finally chamfering process. So we have a remaining stock on the bottom of the part. So to remove the material, we need to do a second operation, which is I call it flip. We need to flip this your model, and then we continue on remove the material on the bottom by using 2D milling operation. So in order to perform that operation, so what I'm gonna do is we will create a new setup, and we need to flip the part, okay? And then we need to select your z-axis and then start all over again. Okay, so this is your z-axis will be top, and then you select the z x-axis, it flip it, and then you need to identify. Okay, in order to have more accurate machining, so we need to select on the bottom of the part. So we're gonna measure this from the top surface. So we will need to select this surface as your reference for the WCS for Z. So to be more accurate, when we want to find the XY, we need the best option is we need to use the uh, features that were machined in the first operation. So as we know that we already drilled this face, so I'm gonna use this one as my X and Y reference. So I need to on my sketch, which is already sketch. So this is my center of the circle or hole. So I'm gonna use here under model body, and then your reference, my origin, I will be selected point. So this is the point that I'm gonna use as a WCS. So my Z will be on the bottom of this face, which is already finished in the first operation, and also hole. So this is uh, some of the method to get more accurate dimension in second operation. Okay, and then under stock, we have to select from preceding setup and click continue rest machining. So by clicking on continue rest machining, we will able to view the remaining stock. So the green color shows that the remaining stock that we need to remove in the second operation. So I off the sketch, and then I go back to 2D milling operation. I can use roughing operation, 2D additive clearing. I gonna use a larger tool, 16 mm or 20 mm, and then we will select the pocket operation, select the surface, top surface, and then click OK, and then we can run simulation, see whether can this operation able not to clear the remaining stock. Okay, as we can see, we need to modify. Seem to me that your roughing operation take too much material in XY direction, which it can cause vibrates and tool wear, as you can see, to take too much material in XY. So I mentioned in previous class, we need to reduce your XY step over. In this case, you go back to your setting into the adaptive. Under process, reduce your optimal load to 15%, which is 1.5. Sorry. So we need to calculate 15% of your diameter 16 means that we have 2.4. And then we have excess material. So we don't need to leave any material in radial. So radial should be 0. Axial, we will set to be zero point 0.5 mm. Okay, so simulate again. Okay, so this is where we can have more acceptable step over. And regarding the cutting parameter, um, for this UITM tooling system, I already optimize the cutting parameter. So no need to change on the cutting parameter for the select tool. Just use a default setting given by uh, the the value that in the file UITM tool. And then we have a remaining stock 0.5, so we need to do a facing operation. Facing, we use tool 95. Okay, for 95, your feed rate is 1000, your spindle speed is 5000. And then make sure you edit and other passes, you don't have any talk to leave tick icon. Okay, so okay. Next, we will do chamfering process on the outer edge and also on the hole side. So since we don't have chamfer features, so we will do 2D chamfer, chamfering, like we'll select on the chin and then the hole and then chin again. Then select okay. Simulate the chin for the chamfering process. Toolbar. Then we see double check whether it's hit or not on the chamfer side. So it seems to me that we need to slightly increase your chamfer to 1. Okay, we have a more can see the chamfer features setting and then on the whole. So we finish on the operation and then we can run simulation from top, and then we can check the total machining time required to complete the operation for the Ops 1 and Operation 2. Then we have another one for the bottom. This is so machining time will be 7 minutes, and the first one is 8 minutes, 8 minute 49 second. So we have estimate about 16 minutes, all without include the setup of the stock in second operation. So that's all for the cam or machining. So before we doing machining, I need to show you how we did post the this cam programming post processing method. So in order to post your process, you need to go to post process to convert the cam operation to G code, and then to find the post processor, I already have this one, your Siemens Cinemeric 840, or you can choose from the library. Okay, you can go for Fusion library, find Siemens Cinemeric. Okay, this is Cinemeric. Okay, then you can download this and use this as a post processor. So post this, and you can see the code produced. Okay, you're using flat anvil or chamfer mill, treadmill, so on. Then this is your phase one, phase mill. Okay, phasing operation, like you have your adaptive roughing and so on. So I think that's all for very quick session on the second operation for 2D machining. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.